So, okay, collector current. Right, this isn't so critical, but it's worth looking at. The collector current, that's the amount of flow going actually through the transistor itself, what it's capable of switching. Right, now on mine it says 7 amps. Right, that is the draw from your primary battery. Right. Now the interesting thing is, ones like this one, as you can see, they're designed to be bolted to a heatsink. So basically, the higher the current that you're switching, right, if you're getting close to its tolerance and you've got one of these, bolt it to a heatsink. In other words, a great big chunk of metal with pins on it. Okay. And if you have a look straight below, it says peak collector current being 14 amps. Right. Don't trust that value too much. The simple reason being that that is when you're pulsing. Oddly enough, that's what the bedini does. But on mine, it says the duty cycle is less or equal to 10%. So in other words, it can only be switched on for, well, 1/10 of a second every second. Right, which, unless you've got an oscilloscope, you will not know, basically. And when your bedini's first spinning up, right, that's probably when you're going to blow it. So ignore the peak collector current and just go for the standard collector current. Right. Now you don't really need to worry about the base current. However, if you're building a supersized coil, right, hopefully you'll know what you're doing and have previous experience. But your base current will need to be watched if you're building a big one. So, that's pretty much the majority of what you need to know. However, there is also something else that makes some of these gold dust, basically. I mean literally gold dust. Right. On page 2, I think it'll be, or image 2, we have saturation voltages. Oh yes, right. In particular, the one that says base to emitter saturation voltage. Right. Now it gives a load of crap after that, but you really don't need to worry about it. Okay. Now, base to emitter, what does that mean? Okay. When the voltage on the base of your transistor reaches a certain level, right, that's when the transistor switches on. Okay. That certain level is what the base to emitter saturation voltage is. So, on mine it says 1.5 volts. Right. Higher is not good. Lower is better. Okay. Very, very simple. Right. The lower that you have that voltage on a transistor, right, the earlier the power coil will switch on, which means you'll get more power. Okay, that's simple. That's what you need to know. Right. Now, for those building sort of either an ultra efficient bedini circuit or something that runs on a low voltage, the one that's above that, the collector to emitter saturation voltage, right, that voltage is the minimum voltage that you can use that it'll handle. Okay, which on mine, this one, is 0.8 volts. So effectively, I can run this transistor using a single AA battery, now 1.5 volt battery. Right. If you could actually build a coil that would handle such a low voltage. Okay. So that's all the technical information that you need to know. The only other thing you need to work out is what the pinning is. So, also on page 2, I think, will be the package dimensions. Right? This will give you a 3D view of your device. This one. Right? It shows you basically which pin is which. So, it's East, C, B, emitter, collector, base. So, as I'm showing it to you now, we'll do it that way. I've got to work out which way is left and which way is right. Starting from the left, base, collector, emitter. That simple. Looking at the diagram, you'll need to rotate it around. Some transistors, when you look them up, they will have different packages available. Right? As in this one that I'm showing you, there's only one type, and that's like that. However, but basically, you can have the 3-pin ones like these. Right? You can have the what I call the diamond package, like the original bedini circuit calls for. You can have an IC type, plastic pin, plastic chip with legs on each side, surface mount. There's all sorts, to be honest. They come in loads of different packages. If you've ever looked on a circuit board and looked at a chip and said, what the hell is that? Go look it up, because it could be literally anything if it's not in a standard package. So that's what you need to know. If anyone does have any problems, then feel free to email me. I don't mind helping. It's just I'd rather teach you guys how to look it up yourselves rather than having to ask all the time. Okay, have fun. Cheers, guys.